So today I'll be presenting a talk on the implementation and analysis of deep learning models for code switch speech classification. I know my name can be a tongue twister for a lot of people out there. So here is a nickname of me. You can also call me Yashi if you find it difficult to call me by my real name. And yeah, I'm currently working as an associate data scientist at AB InBev India with good background in research projects and contributing to open source projects like NumPy. And I have contributed a lot in the Python communities and mostly in the diversity and inclusion space. Before getting started with the session, I would like you to walk through the agenda with me. So first, we'll be going through the problem statement and the background, followed by an overview of the solution that was picked up to solve this problem. Then we'll be diving deeper into the data collection and processing techniques. After that, we'll have a look at the whole pipeline of the process of the convolutional neural network audio classification that was taken. And post that, we'll have a look into the pipeline of the recurrent neural network audio classification. After all of this, we'll have a look at the summary and the resources that was used while I was doing this project. So as I told that I have done a lot of research projects back at my university. So this is also one of the research projects that I did there. So code switching is a condition in which a speaker tends to alternate between two or more languages in the context of the same conversation or situation. Now, this is something which is very common in countries wherein people speak, at least speak two languages or more than that. And they tend to often, switch, go back and forth between those languages while in their conversation. Even in the automatic speech recognition system, which is used in the devices like Alexa, Siri, this is a challenge which is definitely solved by a lot of research which is already going on in this area. But yeah, it still remains a challenge because of the growing globalization. And in countries like India, wherein people tend to know at least two languages, they often code switch while they are conversing. So here's an example. So the words marked in blue are Hindi, and the words marked in pink would be English. So as you can see, the first person says, "Hi, kaise ho?" Now, "kaise ho" is a Hindi phrase of asking, "How are you?" And the other person replies, "Theek hu," that is fine. You tell how things are going. So both the people tend to go back and forth between two languages, and that's exactly what is code switching that is happening. Having a look at the solution. So in this project, I have taken Hindi and English as the two monolingual languages along with the code switch data. So first and foremost, we went along with the data collection. Since the data that we required for this was not very readily available out there in the form of data sets, so we have to manually collect the data. After that, we did the data pre-processing techniques using the different Python library, especially Librosa, through which we extracted the important features that would be ultimately used for building the CNN or the RNN model. So the feature of MEL spectrograms used for CNN model, and the MEL frequency septal coefficients was used for RNN model. After creating these models, it was set on the training and the training data, trained on that, and then it was tested, where it would classify the audio into either Hindi, English, or code switched. Let's dive deeper into the data collection and the pre-processing techniques. As I told that this data was not very much readily available out there as we can find on Kaggle or some other website. So we were provided with a recording extension from our college. And with the help of family and friends, we were able to record the conversations. And then we were able to get some data from the reality TV shows that go on. So this way, we created a data set of 25 hours with 5,000 samples of code switch data that was Hindi and English mixed. and 2000 samples of English and 2000 samples of Hindi. So each and every sample was of 10 seconds long and it was in .wav format. For pre-processing, except for the Python libraries like NumPy, sklearn, Librosa was the go-to package for pre-processing the audio data. This is the package that basically helped us to get the important features like MEL spectrograms and MEL frequency septal coefficients. So, yeah, coming to the convolutional neural network. Now, it was seen that like while we were researching to make this project, we discovered that be it a audio data, a simple raw audio data, or spectrogram images, the convolutional neural network would identify and train well on it that. But it was much better to go for a spectrogram since it's a concise snapshot of the audio signal, and it is a better option as for a data, because it in the convolutional neural network, if you provide image data, that would train much better on that. So that is how we came down to the spectrogram as the data that we would provide. After extracting the spectrogram from the different audio signals that we had, we realized that it was not having a much better heat map that it should have, so that the CNN can train well on that. Now, what spectrogram does is that it creates a graph using the Fourier transform. And a Fourier transform, what it does is it decomposes the audio signal into different frequencies, and then these frequencies are mapped against the amplitude, and that's how a spectrogram is formed. So, since this was not giving the result that we expected, we went up to the MEL spectrogram. Now, what is MEL spectrogram? This is a very common thing that humans tend to hear frequency which is lower, like 100 hertz, 200 hertz. And we tend to identify the difference between them. So if there's a voice of 100 hertz and 200 hertz, we'll be very easily be able to identify the difference between the two sounds. But if the frequency goes higher, like let's say 10,000 hertz and 10,000 and 100 hertz, we won't be able to identify the difference between those two frequencies, because the frequency is very high. We might not be able to completely hear the sound also. So this is the thing, that we tend to identify the difference between two sounds not on a linear scale but on a logarithmic scale. So this thing was solved using a MEL scale, which is there in the research papers that we went through. And on that MEL scale basis only, a MEL spectrogram is formed, which gives a much better heat map for the convolutional neural network to function upon. So we extracted the MEL spectrograms, and then the convolutional layers were pooled for the quality purposes. It was pooled around the labels, the three different labels that we had. We had numerical labels for Hindi, English, and code switched 0, 1, and 2. And for that, then the model was prepared around these labels and the data points as Hindi, English, and code switched. After fully training the model, it was set on the testing data set, and it clearly identified whether which the sample that was provided was which language. So here is a pipeline of the whole process that was adopted. In the audio sound, as you can see here, the above graph is the signal graph that is given. That is the data that we get. After that, the signal in real time graph. Then the graphs that you see below, these are the two heat map graphs of MEL spectrogram. As you can see that they give a much better visibility of the audio waves. And through this, it was identified that a few unique regions in these heat maps, they correspond to a particular label. So on this basis, the CNN was able to identify to which label it could map that particular sample. And this way, the whole model was trained on these MEL spectrograms. the audio waves converted into MEL spectrograms. Then this, as you can see, the convolutional neural network was formed, and it identified the test data into three different classes of Hindi, code switched, or English. Then we went forward with recurrent neural network. So this was the second step that we got. So here, as MEL spectrogram was being used in the case of CNN, for RNN, MEL frequency cepstral coefficients was the feature that was extracted using librosa. So these features were stored along with the labels in an NumPy array, which was then normalized. Here, to form the RNN, we used LSTM, the long short-term memory, for the remembering purposes. And then it was compiled and it was trained on the training data set that we had. After that, the classification was done on the three labels as it was done earlier in the CNN model. Here is a pipeline of the RNN classification. First, the audio sound that was taken into account, the different samples that we have, the each 10-second sample in .wav format. Then the signal in real time, the signal graphs were extracted. After that, the MEL frequency cepstral coefficients were calculated using NumPy, and then the data preprocessing was done. Basically, it was cast into an NumPy array along with the labels, and then the data was normalized. After this, the RNN model was created using the long short-term memory, and then it classified uh, uh, the test dataset into the three categories. Here is a graph of the MFCC coefficients, which is plotted against the time. Here are the summary and the resources that we basically used for our research study that we were doing in the while building this project. So you can go through them. They basically tell you the basics of what is a MEL scale on which a MEL spectrogram was formed, and how is MEL frequency cepstral coefficients calculated. So it is very important to exactly know the math behind of it, because since MEL scale has like a whole mathematical calculation. And after that, the speech recognition with deep recurrent neural networks. This was a research paper through which we went, which basically told us how the RNN function and what all we can implement. Then audio recognition using the MEL spectrogram and convolutional neural networks. So this was basically a research paper through which we were able to exactly make out how MEL spectrograms are helping the CNN and why exactly they are a better choice over spectrograms. This was definitely a great paper to go through. And then the neural model for language identification in code switch tweets. So this was not exactly related to our project, but since it was looking into the code switch data, and initially when we came to the problem statement, we were not really sure what we were dealing with. So this was a good introduction, as it provided us what exactly is code switching and how it is being solved in different areas. Like here, it was in the case of tweets. So you can get in touch with me either on Twitter or LinkedIn. I will be more than happy to guide you in the areas that I have previously worked upon. And thank you.
Thank you very much. Uh, we have a question now. Can you see the screen or
No, I'm not able to see the screen. Shall I stop sharing the screen?
maybe if you? I'm not sure. I can read the question for you. No worries.
Okay.
Narendra is wondering if you also tried 1D CNNs. Not sure what the input features there would be, but in time series tasks, they are sometimes set to combine the best parts of CNNs and RNNs.
Okay, yeah. So this was something that we are still exploring, because initially we were only exploring the deep learning areas, and we came to know like the CNN and the RNN model have different ways of going in this space. So we basically went in diving deeper into like how exactly only CNN solves the problem, and then the RNN.
All right. We still have some time for extra questions. So we have a question from Conrad. Can you also talk more broadly about any differences you saw with English versus Hindi, and or other languages ASR?
So ASR is different. So what happens is like automatic speech recognition systems was what, while we were exploring, we saw that here is a challenge wherein people like it is not specifically on Hindi or English, but on the code switching part, that like they have to identify, like let's say if I talk in Hindi, or I might talk in any other language which might not be a global language, right? So that's what not we were exploring here, but this is definitely a challenge in ASR. But there was a difference in the pattern of the Mel spectrogram on which the CNN was based.
Okay, we have another question from Ganesh. And is your project and data available on GitHub to check?
Okay, so since this was a research project and it was basically for my college, so sharing code would be a bit confidential. So that's why I made it a point to share the resources that I used, the primary resources, though we went through a lot of stuff. But these were the few resources that I found the most useful while preparing it. I can share even more of them after the talk.
Okay, great. You can still have few questions. Feel free to ask. Yes, one more question. Any plans to make your own ASR IoT device? Any future plans for your research?
Yeah, definitely. I would be open to research, but I have not decided to either. I want to, go on the device making, or I would further explore on like how to optimize these models, and yes, create my own personal project so that I can publish it on GitHub. So definitely, I'm open to research, and yeah, I would be doing that.
Good luck with your endeavors.
Thank you.
We can wait for another minute in case any questions came, and if no questions are available, we can wrap up the talk. Okay. Did you try running the models with data that contains noise like English and Hindi spoken by a non-native speakers?
So mostly the data that we obtained here was like the Hindi part was spoken mostly by the native speakers. So and the English definitely it was not native. It was mostly the Indian people recording it. So the Indian English. So there wasn't. If you talk about the noise, so no data noise was there exactly, but yeah, at times when you record the data and the exact words that you want, right? Like the language basically, but there can be a background noise and all that can basically make the data muffled, and so that purpose will have to clean the data before you ingest it in a model or something. Otherwise the feature extraction here would not be accurate at all. So that you have to make sure while you're curating the data, though that's the most initial part, the data collection, but that is the most important part because you need to make sure the data that you're ingesting in the model is right. Otherwise it would be garbage in, garbage out, right? So yeah.